Alrighty. The next thing that I need to talk to you about is why I am bothering you with telling you about stats. Why could you possibly need to know about statistics when you want to study psychology or education or linguistics or human sciences? And there are a whole lot of really good answers to that question. And so part of the rest of today is just talking to you about why you need to learn stats. The first thing that I will use to try and convince you is that statistics memes are amazing, and hopefully you've seen me being very excited and given you guys a whole lot of stats memes thus far. There's someone I learned, there's a whole lot in your lecture slides, including this one right here. So hopefully these stats memes will bring some joy to you and to make the stats part of this course a little bit more bearable, because they certainly just give me a lot of joy. So hopefully they do the same for you. The answer to the question of why you need to learn statistics is partly because statistics is part of the scientific method, and psychology is a science. So psychology, the study of psychology, is about understanding people, understanding behavior and mental processes of humans, but it's actually the scientific study of those things. So what we want to understand as psychologists or as psychology researchers is how people think, why they do things that they do, how they understand the world and take in information from the world and interact with the world, how they develop over time, why they might have issues with mental health, so have some kind of mental health disorders, and how we can best treat people if they do experience problems with mental health. Those are the kinds of questions that we're interested in as psychologists or psychology researchers. And science, the process of science or the practice of science, gives us a framework or a kind of process in order to study all of those things, in order to answer all of those questions. So science is really a tool through which we can study people, through which we can help understand people, and science helps us to answer these kinds of questions that we want answers to. And again, part of the reason why we need statistics and statistical methods and research design and research methods and scientific methods is that in order to get answers to these kinds of questions that we want answers to, we really need a framework to be able to gather information, about people. And we need that framework because simple observation, simply watching people or asking them questions in a really, really simple way, isn't good enough. So I give you complete permission to pause me at the moment and to spend a little bit of time having a look at the amusing things that are currently on your screen. And when you come back to me, I will tell you that the reason that we need the scientific method is because if we have a theory about how people work, about why they do the things they do, or we have a prediction about what might happen if we give people, say, some kind of intervention, or if we try to teach them some kind of skill, if we want to evaluate that theory or to gather information to test the theory or to test the prediction, then we need formal research methods in order to do that properly. Because if we use anecdotal evidence, there are a lot of biases that human beings have that make us tend to interpret information that's consistent with our theories. So if I have a prediction about the fact that if students listen to my lectures in the morning compared to the afternoon, that they will take more in, that they'll get more from the lecture. What I need to do in order to evaluate that prediction is to collect information in the form of data, what we call data, and to use that data to evaluate that prediction, to see if that prediction is true or not, or if there's evidence that's consistent with that prediction or not. And the process of doing that is the scientific method. So this slide just outlines the process that we use when we're engaging in the scientific method for research. And the reason that this is a useful thing is because this is how we get new information. This is how we collect information that can give us insight into human beings, into why people act the way they do, how they think, how they feel, all those kinds of things. So when you're engaging in the scientific method, you start off with a particular theory, and that's up the top here. And that theory comes from a whole lot of different places. So it could come from observation. So you could have observed, you could have watched people doing things, and through those observations you get a theory about how the world works. It could also come through reading literature. So if there's research that's been conducted on a particular area before, you could have a read of that, see what people have found, and therefore use that to form a theory. It could also come from prior research that you yourself or your research team or people that you know have done. So all of those sources of information make us develop this theory which tells us basically how the world works or how a particular part of the world works. And using that theory, we then use that to construct a hypothesis. And a hypothesis is just a prediction about something that we think will happen. It's something that we don't know the answer to yet. So it's a prediction and we don't actually know if it's true or not yet. So my hypothesis could be that students who listen to the lecture in the morning are going to learn more from the lecture compared to those who listen to it at night. My hypothesis could be that the best way to treat depression is through cognitive behavioural therapy. My hypothesis could be that when students are learning to drive for the first time, that going on a drive with a number of different drivers as opposed to just one experienced driver might be more beneficial for them. So that hypothesis is a prediction about the world, and we don't know the answer to the hypothesis. We don't know if the hypothesis is true or not, or if it's supported or not. So in order to get the answer to that, we need to design a research study. And the research study is an experiment or a survey or something that we use in order to collect data. And the data that we collect from the study is designed to be able to address our hypothesis. So to either support or to not support the hypothesis. Once we've conducted the study, then we need to analyze the data. And this is where statistical methods come in. The statistical methods allow us to aggregate, to summarize the information that we've collected, and to perform analyses on that in order to see if we have support for our hypothesis or not, to see if the data, the information that we've collected, support the hypothesis or if they don't support the hypothesis. And based on that data and that analysis that we do, we can draw conclusions about whether we have evidence for or evidence against our hypothesis. That is the scientific methods. That is the process of conducting research. And as researchers, which are all of the academics that you'll come across in your time at uni, as researchers, this is what we do. We go through this process again and again to get new information about the world. And based on the conclusions from any one particular study, that then goes back to inform our theory, to refine our theory about how people work or how people think or act or behave. So that's the scientific method. And the scientific method is essential for psychology because, as I said to you before, psychology is the study of human behavior. We want to understand how people think, how they work, how they interact with the world, how they process the world. And you might be sitting here studying psychology as a first year student thinking that what you really want to do is to go into clinical psychology or to go into counselling. So this is probably what the majority of students who are studying psychology at first year want to do or think they want to do at this stage. So it's very reasonable that you might think that what you want to do with your life or with your degree is to become a counsellor or is to become a clinical psychologist or is to become some kind of practitioner. You might think that you don't want to become a researcher, you want to practice psychology. And the scientific method and research is as essential for clinical psychology as it is for other areas of psychology. Because in clinical psychology, what we're interested in understanding is mental health issues. So why some people develop depression, develop anxiety disorders, develop bipolar disorder, what the best treatments are for those people, how to help people through relationship issues, how to help them through family issues, how to help them with dealing with stress and anxiety in their life. And the answers to those questions are given to us through research, through developing hypotheses about what the best treatment is or what the best way to think about your problems is to overcome the problems that you have or to deal with the stress. Research methods are the way that we gather information to be able to answer those questions. So the slide that's on your screen at the moment is a really interesting article that was published in this journal called Nature. Nature is one of the most prestigious journals in the world, academic journals, and it's a journal that publishes academic articles. And this is a really interesting article which is talking about how essential science is to clinical psychology. It's particularly talking about the US system, but I strongly recommend that you have a look at this article. It's freely available online. It's an open access journal, which means you don't have to have a subscription to be able to access the articles in the journal. So it's a really interesting article that just talks about how essential science and the scientific method is to clinical psychology. Okay, so what we need to do, as I said to you already, in psychology is to use the scientific methods and specifically formal research methods, the idea of designing studies to address hypotheses, in order to answer the kinds of questions we're interested in as psychologists or psychology researchers. So some of those questions could be, what's the most effective therapy for people with clinical depression? Is it psychological therapy, something like cognitive behavioral therapy, hypnosis, relaxation? Or is it pharmacological therapy, drug therapy, antidepressants? We need science and formal research methods to be able to know the answer to that question. We could also have a question such as, does exposure to childhood trauma increase your chance of developing psychopathology later in life, so psychological problems? Do kids who are exposed to very adverse life events early in their life, are they more likely to have mental health issues later on? We need formal research methods to answer that question. We could also be interested in applied psychology. So for example, we could be interested in wondering whether anti-speeding ad campaigns are the kinds that governments spend a lot of money implementing. Are they actually effective in decreasing people's speeding behaviours? Do people drive more safely after they've been exposed to these kinds of campaigns? Again, this is a question that we need science and formal research methods to be able to address. We could also be interested in wondering about gestures. So if kids use gestures when they're speaking, does that actually help their understanding of some information compared to kids who don't use gestures? We could be interested in health psychology and thinking about whether people with chronic pain are more prone to developing depression, say, compared to people without chronic pain. So these are all questions that need science and formal research methods in order to gather information in the form of data to be able to address these questions. Okay, so maybe I've convinced you, hopefully I've convinced you by now, that science, the scientific method, formal research methods are essential to psychology. And you might be thinking at this stage, okay, science seems important, but why statistics? Why do we need statistics? Why do we need to think about numbers and all that kind of stuff? So that's my next point. Why stats? And the answer to that is statistical methods are actually a really essential part of the scientific method. We can't use the scientific method to answer those kinds of questions we're interested in answering without specific statistical methods, statistical tests to be able to evaluate data. So going back a couple of slides when I had the flow diagram of the scientific method, the analysing data part, that's the stats part. That's the part where we need statistical methods to be able to evaluate data, to summarise data, and to see if the data that we've collected, the information we've collected, actually supports the hypotheses that we have. So as psychologists, as psychology researchers, the kinds of scale that we're usually interested in are people in general. So as psychologists, as psychology researchers, the kinds of questions we have are usually about people in general, people on a big scale, people across the world, people across Australia. We could be interested in adolescents in general, so how adolescents develop, what adolescents are thinking and feeling. We could be interested in chronic pain sufferers, people who experience chronic pain. We could be interested in individuals with certain kinds of psychopathologies like PTSD, post-traumatic stress disorder. We could be interested in novice drivers, so people who are learning to drive for the first time. What we're usually interested in are people in general on a big scale, and I call those people our population. And I'll talk more next week about what a population is and how it's different to a sample. But the people on a big scale is the population that we're interested in. Those are the people that our research question applies to. So if I'm interested in wondering whether pharmacological therapy, drug therapy, or psychological therapy, talk therapy, is more effective for people with depression, I'm usually interested in all people with depression, or all Australians with depression, or all people in the US with depression. I'm not usually interested in one person. I'm interested in people on a bigger scale. The difficulty with that is that people are complicated, as the great cartoon on the side represents. People tend to vary. People are different. Not everybody is the same. So if I have one person with depression, their experience could be quite different to another person with depression. If I have one novice driver, their experience could be quite different to another novice driver. People tend to vary. There's variation. People are different a lot of the time. And the other problem that we have is that even if I might be interested in all people with depression or all Australians with depression, I actually can't collect data from everybody, or most of the time we can't anyway, just because it's not feasible. I could be interested in people's experience with depression, but I can't feasibly look at every single Australian who experiences depression and ask them about their experience. That's just not doable. So people are complicated, people tend to vary, and we can't get information from everyone, from all of those people. And because of those two issues, that is actually why we need statistical methods, because statistical methods help us to aggregate, to summarize across people, and that helps us to deal with the issue of variation, of differences across people. And statistical methods also help us make inferences or generalizations from a smaller group, which I'll call a sample, back to a larger group, which I'll call a population. So if I'm interested in all Australians with depression, I could gather data, collect data, ask questions from a small sample of that population, and based on the data that I've obtained from that sample, I can then make generalizations about what I think is happening back in the population, in that wider group. And that process of aggregation, of summarizing information, and making inference, making generalizations from a sample to a population, that is the fundamental concepts of statistical methods. And that's essentially what we're going to be talking about, just with slight variations and slight details throughout the rest of the semester. So if you take nothing else away from this lecture, this slide is probably the most important one. That the reason that we need statistical methods is essentially because people are complicated, they vary, there's differences between people, and therefore we need to try and find a way to aggregate or to summarize across people. And also, we can't actually get information or collect data from everyone that we're interested in. We need to make some kind of inference from a smaller group, which I'll call a sample, back to a larger group, which I'll call a population. And that is what statistics helps us do. It's what it allows us to do, is to aggregate information, to summarize information, and to make an inference from a sample back to a population. So I thought I'd give you an example of kind of the scientific method as applied here to hopefully draw out these concepts in a little bit more detail. So let's say that we had a research question. It's a clinical psychology research question, and that question is cognitive behavioural therapy, CBT, effective in treating a particular type of anxiety disorder, which is called generalized anxiety disorder? So that's our research question. That's the thing we're trying to find out information about. Is CBT effective in treating generalized anxiety disorder? Using the scientific method, we would then design a study, and that study could be a randomized controlled trial, which is what RCT stands for, looking at anxiety over time. So we could have anxiety measured pre-intervention, before our CBT intervention. We could have it post-intervention, so after our CBT intervention, and then 2 months later to see if any benefit that people get lasts over those 2 months. So let's say that we get a sample, and our sample are going to be people with generalized anxiety disorder, and we could randomly allocate our 200 people who make up our sample to these two different groups. We have a control group and we have an active therapy group, a CBT group. So we've got 100 people in each of those groups. What we need statistics and what I'll call quantitative research methods, which is a particular type of research methods where we're measuring stuff. We're measuring stuff in a kind of numeric or a number-based way. What we need these particular research methods and statistical methods to do is to be able to summarize these anxiety scores across all of our participants. So to aggregate them, to summarize the individual scores, the anxiety scores themselves, across all of our people. Because of course, not everybody is going to have the same anxiety score. There's going to be variations. Some people will be more anxious, some people will be less anxious. So statistical methods can help us summarize, aggregate those scores across all of our participants. They can also tell us whether there's a decrease in anxiety in our cognitive behavioural therapy group, our active therapy group, compared to the control group. So if CBT is effective in treating generalized anxiety disorder, we would see a decrease in anxiety in our active therapy group, the CBT group, compared to the control group. The control group shouldn't get much of a change in anxiety, we would predict, whereas the CBT group we would predict would have a decrease in anxiety. And statistical methods can also allow us to see how likely it is that any decrease in anxiety that we see in this sample of people in the CBT group, how likely it is that that change in anxiety, that decrease in anxiety, can be generalized to a wider population. So that process of seeing what the change is like in our sample and how likely it is that that change is reflecting a real effect or a real change in our wider population. This is the fundamental process of what I'm calling inferential statistics. So statistical methods that can allow us to see if we have a pattern in our sample being the people that we've actually actively recruited for this study, and to see how likely it is that that pattern that we see in our sample is reflecting an effect or a pattern, the same kind of pattern, in a population, in the wider population. And the population here is all individuals with generalized anxiety disorder. So those are just three details, three specific ways that we would need statistical methods to address that research question in this particular example. The next thing I want to do to hopefully convince you about the importance of stats is that statistical methods, so the learning of statistical methods for you guys who are here learning psychology, it's not only important if you want to become a psychologist or a researcher or a linguist or an education researcher, say. It's actually really beneficial, in my biased opinion, for anybody. And the reason for that is because what learning statistics and research methods does for you is that it helps you develop your critical thinking skills. So critical thinking being the process through which you can evaluate information, evaluate something that you're told, something that somebody is trying to convince you of, and to evaluate that according to how likely it is to be true, or to think through the facts that you're presented with, or to think through the argument that somebody is trying to convince you of. So critical thinking, developing the critical thinking skills is probably the most important thing that you will do at uni. So learning stats, learning scientific methods and learning statistical methods is going to help you develop critical thinking skills. And I'm going to give you an example to hopefully ram that home. So living in Sydney, as I'm sure the majority of you do, we know that a couple years ago there were these particular laws introduced called the lockout laws, which were designed to try and curb alcohol-fueled violence that people would engage in when they've drunk too much and get very stupid. So the New South Wales government developed these particular laws, put them in place in order to try and decrease the amount that people would drink and decrease the amount that people were drinking out, and therefore hopefully to decrease the amount of violence that people engage in. So this here is a quote by our then Premier Mike Baird that he put up on Facebook in February 2016. So what he said was, "Let's start with a statistic about Sydney's nightlife that matters. Alcohol-related assaults have decreased by 42.2% in the CBD since we introduced the lockout laws, and they're down by over 60% in King's Cross." So here the Premier is trying to convince us that the lockout laws had a positive effect because there's been such a dramatic decrease in the number of alcohol-related assaults. He's trying to convince us that this is a good thing because he's a politician and this is a lot of what they do. But if we have our own ability to think through information, to evaluate information, and to use our kind of common sense to think this stuff through about whether that's realistically true or not, then we might have a slightly different opinion about it. And this particular example, we can use other information that we have about, say, these statistics, say the amount of violence that people engage in different parts of the city, to be able to evaluate this claim that he's making. And in particular, in this instance, there was actually already a decline in alcohol-related violence, alcohol-related assaults, before the lockout laws were introduced. So there was already a decrease in the amount of violence that people were engaged in, and the lockout laws therefore can't take responsibility for that decrease because that decrease came before the laws were introduced. So if we as people in the world, if we have the ability to evaluate information and to think through information that we're being presented with, that we're trying to be convinced of, that is going to be a good thing, because it means that we are less susceptible to people trying to convince us of things that aren't necessarily true or don't necessarily have evidence that they are true. So in this instance, the lockout laws did have an effect on violence, well, according to the information, as much information as we can see anyway, but it wasn't as extreme an effect as the Premier was trying to tell us it was. And that's just a link to the Sydney Morning Herald article that's talking about this. So in this current world that we live in, which is a slightly crazy world of having a lot of fake information on the internet and fake information being kind of talked about and being spread around by media and various things, this area of fake news, having critical thinking abilities, having the ability to evaluate information, to think sensibly about information and not just believe things because people tell you that they're true, is a really, really good thing. And there's a link down the bottom of that slide, of this particular slide, to a couple of different articles that are talking about essentially how we can use science and the scientific method and just our ability to evaluate information and to think about information to try and counter this whole fake news phenomenon that's happening at the moment. And it's really important, in particular, one particular area that's really important is the area of health. So this is a slightly biased opinion because I work in health psychology, but when we think about health and about people's health, and when we couple that with advertising and big business and people trying to sell stuff, there's the potential for a lot of very misleading information to come out. So one example on the left-hand side there is the company Nurofen, the drug company that sells ibuprofen medication. And Nurofen a couple of years ago started advertising these different kinds of Nurofen tablets that were targeted to different kinds of problems. So you can see that there's back pain, there's period pain, migraine, and tension headaches. And they told people that the medication itself was different to be able to target different kinds of pain. So the tension headache type of Nurofen was different to be able to specifically target tension headaches compared to the migraine Nurofen, compared to the period pain Nurofen, compared to the back pain Nurofen. Treatment or something is actually a really important thing, because companies want to sell things at the end of the day. That's what companies want to do. And so often you'll be the case where there's a lot of very misleading advertising or very misleading information just to be able to try and get you to buy something, to spend more money on something. And similarly, on the right-hand side of the slide here, this is another article from the ACCC, which is the company that kind of regulates advertising and these kinds of things, where there was a fine for a company called Homeopathy Plus, who was selling homeopathic medication or homeopathic treatments that claimed that it was as good as vaccinations, that claimed that the homeopathic medication was as effective in preventing whooping cough and other kinds of things that vaccines are there to prevent, even though there's no evidence of its success. There's no evidence whatsoever that these kinds of homeopathic medications are in any way effective, let alone as effective as vaccines, for these really horrible diseases like whooping cough. So hopefully you can see that your ability to think critically about information that's presented to you, particularly in terms of advertising, and I think health psychology is a really interesting area because there's just so much stuff that people try to sell you to help your health or to improve your health or to benefit your health. That's really misleading, and kind of best case it's just misleading, at worst case it's actually potentially very dangerous for people. And down the bottom of this slide, I've got an article from The Conversation. If you're not familiar with The Conversation, it's a news website that's designed to communicate research findings, kind of academic findings, to a wider audience. So it's a really great website that's got a whole lot of really interesting stuff about psychology and everything else. And it's an article talking about how, as academics or as people who are familiar with academic research or academic work, how we can try to combat particularly politicians who try to misrepresent information or misrepresent data to a wider population, or wider public. Okay, so hopefully I have convinced you that statistics is actually really important. Science is really important, the scientific method is really important, because that's how we find out new information about the world, about people, about why people do the things they do. And statistics is a very fundamental part of the scientific method. Statistical methods, statistical analyses help us to aggregate information, to summarize information in the form of data that's been collected, and to be able to make generalizations or inferences from the data that we've collected back to a wider population. And I'm going to talk more about that over the next couple of weeks, because that's a kind of complicated and very important process for you to wrap your head around why that happens and how it works. But that's essentially the fundamentals of why we need statistics, is because, as I said a couple of slides ago, those two really important points, that people vary, people are different, people have different kinds of experiences, and we need to be able to learn something about a wider population from data that we collect from a smaller subset of that population called a sample. Hopefully you've noticed throughout the lecture thus far that there are a lot of very amusing things, or at least amusing to myself, hopefully amusing to you, on the slides in the form of memes. One of them on this slide is just an example. I've given you the link of a Facebook page there called Fake Scientist, and it's just very enjoyable. It's very silly and it's very enjoyable, so hopefully you get some enjoyment out of it, even if it's not quite as much as I do, because that's possibly not possible. Okay. This next slide is giving you a couple of references, resources, links, websites that give you, I think, an insight into the wider importance of science and research in terms of society and in terms of helping our understanding of the world. So this is by no means an exhaustive list. This is just a couple of things that I thought might be useful for you. Science or Not website is a really useful kind of pop science explaining things about the world. The Conversation, as I mentioned before, is a news website designed to communicate information about research findings or academic findings to people. There are a lot of really great psychology podcasts out there, or kind of just science podcasts or human interest podcasts. One of them that I've linked there is called All in the Mind, which is particularly about psychology and neuroscience and mental health, which is an ABC program, but there's a heap of them out there, so hopefully you can discover some of your own that you find interesting. And then the last link is a kind of online website magazine type thing called Psychology Today, which works to communicate psychology findings as kind of news articles or easily accessible articles. And it does a really great job of explaining scientific and psychological findings there. All right, the next thing I want to talk to you about, because it's a week one lecture and I'm kind of easing you into the course here, is statistics anxiety. So I promise that Grumpy Cat is not true, that we don't make you learn stats because we want to make you unhappy. I promise that's not the case. Statistics anxiety, or just feeling anxious or nervous about stats or maths or this part of psychology, is really common among psychology students, or any students who have to learn statistics when you're not enrolled in a stats degree or a stats course. So you're all here because you want to study psychology, and you probably didn't think that statistics was a big part of psychology when it actually is. So what I don't want to do is to make you anxious if you're not already anxious. Absolutely not. And I have to tell you that when I was a new first-year student, when I was first studying psychology, and I would tell people that I would meet that I was studying psychology, one of the most common things people would tell me is, oh my God, statistics, you have to learn statistics. It's going to be so hard. It's going to be a nightmare. And it genuinely made me anxious to learn it. So I don't want to make you feel that. I promise it's not going to be a nightmare. I promise it's not hard. But at the same time, I want you to understand that it is common to feel anxious about it or to feel nervous about it. And that's because you are here doing psychology, studying psychology, not studying maths or stats. So I want to assure you that I am not here to try and make you statisticians or mathematicians. I myself am not a statistician or a mathematician. I'm a psychology researcher. So what we're doing isn't actually fundamental statistics, it's applied statistics. It's statistics as applied to psychology research and psychology research questions. So all the stats that we talk about, even if there are some slightly more mathsy aspects of it, it's all to be able to answer psychology research questions. And I promise it's not as bad as if you were going to do a stats course or a maths course. Having said that, something that might make you feel better if you feel like your math skills are particularly rusty, if you feel like there's some basic mathematical skills that you're a little bit unsure about, maybe you haven't done it in a while, maybe you were never particularly competent in it or confident in it to begin with, some revision is going to help you. So we live in the age of the internet where there is we live in the age of the internet where there is anything you could possibly want available online to you. So there are heaps of maths revisions, kind of high school maths revision stuff out there. I've given you the link to one particular resource, which is called the Khan Academy, which is fantastic. I'll be referencing it a couple times throughout the semester because it has a heap of free online lectures, really good online lectures about a whole lot of different kinds of things, including maths and statistics. And I've listed a couple of topics here which, in my opinion, are the most relevant for you. So if you feel like your basic arithmetic is not great, then that might be something you want to brush up on. If you feel like your basic algebra is not great, then that will be something you want to So I've listed just a couple of topics here that I think will be relevant for you. If you feel like your basic arithmetic, kind of adding things together, subtracting, multiplying, dividing, if you feel a bit rusty on that, then you might want to brush up on that. Algebra is a good thing to brush up on, geometry, basic probability. These are just a couple of things that we're not going to be talking in a lot of detail about, I promise, but they are the basis of some of the formulas and some of the concepts that we'll be talking about. So if you don't feel particularly competent in that kind of stuff, then I definitely recommend that you have a look. And the Khan Academy is a great place for a lot of really basic resources, basic kind of high school level stuff. I promise I don't expect anything beyond that for you, and anything that is more complicated we'll be going through and I'll be teaching you throughout the semester. But some of that basic stuff is assumed knowledge. We do assume some level of competency with those sorts of things. So if you're feeling anxious about it, then revise it. That's the best way to make yourself feel a bit more comfortable with it. I also wanted to show you this paper, which is it's actually a really interesting paper if you feel like reading it. It's it's published in an open access journal, Frontiers in Psychology, so you can freely access it online. And because statistics anxiety is such a common thing, there's actually a lot of research published in it, which is really interesting. Ways to try and get students to overcome their anxiety about stats, or to try and understand in more detail why people are so anxious. And this is one particular paper which is talking about the benefit that could come about from having a high statistics anxiety. So you probably think that anxiety is a negative thing because it might kind of interfere with your skill. It might make you paralyzed with anxiety. It might make you freak out so much you can't necessarily perform as well. But they actually talk about dual effects of anxiety, a negative effect and a positive effect. And there are some positive effects to anxiety which do make you study harder, make you a little bit more alert when you're completing an examination, something like that. So I thought I'd just throw that in case anybody is particularly interested in reading the paper. It is quite an interesting paper talking about the mechanisms of anxiety and the outcomes of anxiety.